Do you know what does this formula mean and what it is called? In this video, we will learn about that. But before that, don't forget to subscribe our channel. So, Assalamu alaikum guys. Welcome to NoorulRiazi and this is your mathematics teacher Nuruddin Qureshi. And in this video, we will learn about the Heron's formula. So first of all, we will see what is actually a Heron's formula. So if we have a triangle with three sides A, B and C, where S is equal to the semi-parameter of the triangle. That means if A, B, C are three sides, then S will be equal to A plus B plus C upon 2. Then area of the triangle can be given as under root S into S minus A into S minus B into S minus C. From where this formula has come from, so we will try to prove this formula. So according to the cosine formula, c square, that means the square of the third side, is equal to a square plus b square minus 2ab into cos c. That means you can say that if this is the third side and you have two sides with an angle between them, so the square of the third side is equal to the sum of the squares of other two sides minus twice the product of AB into cosine of C. So this is the cosine formula that we will study deeply in detail in the trigonometry section. So isolating cos C, we will get cos C is equals to A square plus B square minus C square upon 2AB. Let's call it our equation 1. But we know that sine theta is equal to under root 1 minus cos square theta. This is a general rule, but again in detail we will cover it in our trigonometry section. So let's call it our equation 2. So by combining equation 1 and 2, that means putting the value of cosine from equation 1 into equation 2, we will get sin c is equal to under root 1 minus a square plus b square minus c square upon 2ab to the whole square. Now expanding it, we will get sin c is equal to 4a square b square minus a square plus b square minus c square whole square upon 2ab. So 2ab was a square, so after taking the LCM we have taken it out of the square root, so it will become 2ab. So then we will call it equation 3. But also we know that area of a triangle is equal to half into AB into sin C. That means if we want to find out the area of a triangle with given two sides and an angle between them, then area is given as half into the product of two sides into sine of the angle between them. So let's call it equation 4. So putting the value of sine from equation 3 into equation 4, we will get area is equal to half AB under root 4a square b square minus a square plus b square minus c square whole square upon 2ab. So now this AB and this AB will be cancelled and 2 will be multiplied by 2. So we will get area is equal to 1 upon 4 under root. So now in under root, as you can see, so this is a complete square and this is also a complete square. So with a subtraction in between, we can call it the formula of x square minus y square, which can be expanded as x plus y into x minus y. Now 4a square b square is the square of 2ab, so 2ab and 2ab is here, and similarly this is also a square of a square plus b square minus c square, so this is here and here. So now as you can see, we have got two brackets here which are being multiplied with each other. So now in the next step, we will arrange to form a perfect square equation. So we will separate c square and we will put the terms of a and b together in this bracket and in this bracket also. So it will become like this, where a square minus 2ab plus b square, which is the whole square of a minus b, and similarly a square plus 2ab plus b square, which is the whole square of a plus b. So in the next step, we will write it like this. So under root c square will remain a c square, a square minus 2ab plus b square, we will factorize it into a minus b whole square, and similarly a square plus 2ab plus b square, we will factorize it into a plus b whole square. Now in the next step, we will again expand it. How we will expand it? Because you can again see that this is a whole square subtracting a whole square, and again this is a whole square subtracting a whole square. Again it will become x square minus y square, so it can be expanded as x plus y and x minus y. So by expanding it, c square minus a minus b whole square, so it will become c minus a plus b and c plus a minus b. And similarly, a plus b whole square minus b square will be expanded at a plus b minus c and a plus b plus c. Now in the next step, we will put 4 again into the root. So outside the root it was 4, so inside the square root it will become 16 because the square of 4 is 16. And then we will distribute the 16 into all 4 brackets by 2 into 2 into 2 into 2. As you can multiply 2 with the power of 4, you will have 16. So we have distributed 16 into 4 2s. So now as you can see that apart from the last bracket in which all 3 terms are positive, that means a plus b plus c, in these 3 brackets one of these is negative. So to have a similarity between all 4 brackets, we need all 3 sides in a positive term. So in the bracket, whichever side is negative, we will add and subtract term for that side. So for example, there a is negative. So in the next step, we will add a and subtract a. So a was already negative, subtracting 1 again a, it will become minus 2a, and the extra a added will have this. So again, if you add these again, it will become like this. Similarly here, b was negative, so it will become like this, a plus b plus c minus 2b. And similarly here, c was negative, so minus c plus c will be added here, so a plus b plus c minus 2c, and it will remain like this. So now in the next step, we will separate the 3 positive terms with the denominator of from the negative term. So here it will become a plus b plus c upon 2 minus 2a upon 2. Similarly here b was negative, so a plus b plus c upon 2 minus 2b upon 2. And here c was negative, so a plus b plus c upon 2 minus 2c upon 2. And it will remain like this because in this bracket all 3 terms were already positive. So now as you know that the semi-parameter of a triangle is given as a plus b plus c upon 2, or you can simply generalize this term as S. But by definition, S is the semi-parameter in which all 3 sides are added divided by 2. So replacing this, we will get the formula of area, which is S into S minus A. So this is S minus 2 cancelled A into S minus B. This is S and 2 cancelled B, and this is S cancelled. This is C. So area is equals to S into S minus A into S minus B into S minus C. So this was the proof and the basic derivation for the Heron's formula. I hope you liked our video. If yes, then do like it, give your feedback in the comment section, and share this video as much as possible. And if you like the concept of NoorulRiazi, then do subscribe our channel and follow our Instagram page with the same handle. So see you guys in the next video.